Sir, madam, we have found a solution for our sample transportation problem.
No, you shouldn't be here.
No, sir. You don't understand. This will be really helpful for our current research park.
Okay, but what do you mean by this squadrone?
So, let me show you something.
In a world driven by technology, the sky has become a canvas for innovation and possibilities. Drones, once a mere fascination, have evolved into powerful tools reshaping our lives in astonishing ways. Among them, the Squadrone stands out, a symbol of technological prowess and groundbreaking advancements. Powered by hydrogen peroxide, this remarkable drone has revolutionized the world of delivery services. Behind the Squadrone lies a dedicated team of engineers and researchers who have harnessed the power of chemical kinetics and collision theory. By understanding the intricacies of H2O2 decomposition and optimizing its concentration, they have unlocked the potential for efficient and resource-conscious delivery.
But there is an obstacle. We have been asked to successfully deliver the sample while minimizing the waste of hydrogen peroxide resources.
Our goal is to maximize success rates while minimizing H2O2 consumption and ensuring sample integrity. Through rigorous analysis and cutting-edge technology, they seek the optimal balance of effectiveness and efficiency. With each experiment, they come closer to determining the optimal concentration, reducing waste, and advancing scientific discovery.
Armed with cutting-edge technology and unwavering determination, these scientists push the boundaries of innovation. Their mission is twofold: to maximize success rates and ensure sample integrity, all while minimizing the consumption of a precious resource, H2O2.
As we all know, we need to pour more oxygen in a short amount of time so that the drone could fly higher and longer. To achieve this, we need to increase the reaction rate of the hydrogen peroxide. Firstly, let's analyze what are the factors that affect the reaction rate. First of all is the concentration of the reactant. The more concentrated the reactant, the more molecules present to collide with each other. Thus, the reaction rate is higher. Secondly is the temperature of the reactant. Let's see an animation to get better understanding. As you can see, the higher temperature will increase the kinetic energy of the molecules. Reactant molecules will move faster and increase the chance of colliding with each other, increase the rate of reaction. Other than that is the presence of catalyst. Catalyst speed up the reaction by lowering the activation energy barrier, hence more effective collision will occur and rate increase. Now we are moving to determine the initial concentration of hydrogen peroxide H2O2 at 4 different seasons. From this information, we could plot a graph by using Arrhenius equation by plotting graph of ln k against 1/T. From this graph, we can find the gradient, thus finding activation energy by using this equation. From the equation, the lower the activation energy means the higher the rate constant, thus the higher concentration. We can also find the Arrhenius constant by using this equation. From this graph, we choose as reference to determine our initial concentration of hydrogen peroxide. By having the activation energy and the Arrhenius constant, we can manipulate the temperature to determine the rate constant as well as the concentration to use. We choose Canada as a country that has 4 different seasons. Each season gives us different temperature, hence different concentration to use. Then we can calculate to find the rate constant. As well as the concentration. The higher the rate constant, the higher the concentration. So this is the initial concentration of hydrogen peroxide to be used at 4 different temperatures.
Now let's talk about sustainability. Sure, these drones are great technologies. Transportation of samples all across Research Park, especially during task season, are now made possible. However, this hydrogen peroxide fueled drone, if we're used in a large scale, is going to damage both the environment as well as the human's health. That's why our team has come up with alternative as well as inventions of technologies for the waste disposal process. Let's start with our first proposal, recycling and reusing the waste. Did you know that hydrogen peroxide is actually recyclable and can be reused to do a lot of many things? Our plan is to collaborate with waste management companies that will help in guiding us in sorting as well as putting those hydrogen peroxide waste and reusable parts of the drone to good use. And our second idea, introducing our waste disposable vessel, and this is a reaction tank that is made of materials that are compatible with hydrogen peroxide like glasses and polypropylene. In this tank, dilution and neutralization will take place with controlled temperature to lower the concentration of hydrogen peroxide before decomposing it. And we believe by doing all this hard work would help us in achieving our SDGs or Sustainability Development Goals, which are to maintain clean water resources, care for life on land, conduct responsible consumption production, as well as build partnership towards goals.
So based on our calculation, we need to determine whether the reaction is non-spontaneous or spontaneous, and whether they are thermodynamically favored or unfavorable. This by using Gibbs free energy. The standard enthalpy change of hydrogen peroxide is approximately negative 98.2 kJ per mole. The negative sign shows that the reaction is exothermic, which means heat are released to the surrounding. Next, calculated entropy change, which is delta S, negative 63 joule Kelvin per mole for the decomposition of hydrogen peroxide. Gibbs free energy. It can be calculated by using the delta G equals to delta H minus T delta S. When the value of delta G is negative, the reaction will be spontaneous, and non-spontaneous when the value of delta G is positive. In this project, we can conclude that when the temperature decreases, the reaction will be spontaneous. Based on our calculation, summer and spring season have higher temperature, hence they are non-spontaneous. So external forces are needed to make them spontaneous. So what we can do, we can lower the temperature of hydrogen peroxide in the drone.
For our research, there are a few things that we want to improve on drone, which one of it is maximize the reactions rate of the result, reduce the fuel consumption. There are 4 ways to increase the reactions rate. They are concentration of the reactants, reaction temperature, the presence of catalyst, and physical state of reactant. Catalyst we can add into the reaction magnesium 5 oxide or lead 5 oxide. We are also planning improving the drone's aerodynamics, reduce weight, and enhance the propulsion system. The battery should also be upgraded and evaluate the drone's payload capacity so the drone can do its work more efficiently. Thank you.
So, what do you think about proposal?
I like the idea. The deal